All right, welcome back. And here we are again. I'm Corey. We are in the middle of building a custom programming language in C++ using tools such as Bison and Flex. And yeah, we're just every episode we're trying to get a little bit more of it done. And again, I'm doing it all in front of you. I'm not using any fancy IDEs. I'm using Vim. Okay, let's face it, it's pretty powerful, pretty fancy, but I am not a power user. I'm One of the reasons I'm doing this project is just to better learn Vim, to better learn C++ as well, and to better learn, make files and just all that stuff. If you want to learn something, build something. So, anyway, alrighty. I have done a few changes off camera since the last video. Not very many, but a handful. And let's cover them. So you can see here that episode 14, that was the end of our previous episode. And so we can look what we did. First of all, I had broken out in the previous ones. Everything was, all the AST node stuff was in just a file called AST, and I was going to have one really big file. And I thought, no, I should break each one out individually. So that's what I did, breaking it out, and as such, AST node was now the outlier. It was in a file called AST instead of AST node, whereas everything else was in a file that used its name. So okay, so I fixed that. I moved those files and made all the changes. So instead of pound include ast.hpp, you were now pound including AST node.hpp. Yes. All right. Updating the documentation. I do that at the end anyway. Then I took, so in our program.cpp, there was, of course, the method dump bytecode and execute. And I happen to know that these are going to get big, and there's no reason to keep them in the same file. So I broke those out, and the name, let's see, what is the name? I always forget, src. Source, here it is, program dash. Since it's part of program, but it's its own thing. And so for dump bytecode and for execute. And those, I just broke them out. And then updated the docs again. And then I found one other thing. I had never written any documentation for the operator plus of garbage collected. So I did that, updated the documentation, and now we are, it's all on the repo anyway, but it will be part of episode 15 when I make that push. So again, as the only thing I think I want to add is I don't have descriptions for all of the files, and I definitely don't have any for the CPP files, but I'm probably going to go back and add those descriptions. But okay, enough of that. Let's jump into making more math. And specifically, we're going to see if we can implement the subtraction, maybe multiplication. I don't think we'll have time to do subtraction, multiplication, division, and modulo, specifically because division and modulo, we have to worry about divide by 0 and check for that. And so just a slight bit more work. And I'm hoping I can do this in an hour. You may have noticed, say, Corey, it takes a little while to get through these things. And I would say, yeah, that's programming in general. And to make sure that everything is written appropriately. And so, yeah, let's just jump in. First, before we start, like I said, we know we're going to do a subtraction. And I'm going to edit the make file first. And let's see, we've got our AST node add. We're going to need an AST node subtract. And let's just add it here. And I didn't try this, but let's see if I can do the %s/ and I want to change add slash subtract slash, ooh, I don't want it G. I just want it on this one line. So I think it's S for the one line. Or I could say I'm on line 56. I could do 56 comma 57. That should work. But then do I just say S slash? I haven't tried this, so we're gonna. In fact, I had a window that was just kind of like my cheat sheet, just in case. No, there should be a space. Okay. S slash. I could have had it done by the time I'm doing this. Add, and I'm going to subtract slash, and I think it's G. Yes. Okay. So now we've got node subtract, compiling AST node subtract. I'm happy about that. Okay, we are going to quit while we are ahead, and should be able to use that in additional stuff here. So now, in our source, I just want to look at it. Oh, we need to do it for, no, we don't need to do it for a computed expression, just AST node. So I'm going to copy AST node add, and we're going to call it AST node subtract.cpp, and I'm going to copy the include of AST node add and call it AST node, include AST node subtract.hpp. Okay, so I've copied the add for the HPP and the CPP. Let's make a few changes. AST node. Sorry, yes, I'm thinking. Include AST node subtract. There we go. And also the source AST node subtract. There we go. For this one, we want to change all of the adds to subtract, and so can I do this? %s, I think, slash add slash subtract slash G. And look, it did the pound include. We've got our subtract. What's the... It didn't change that, but that's fine. So we're going to need a subtract. Why did it move those up? Well, I know why. Because I hit J, and it was a Shift J. There we go. Okay. I think all of that's right. We need to do it here, the AST node add, again, to subtract. So, again, colon %s, and we're going to add to subtract globally. Did it do it? Yeah, it did. Okay, we need to do it again. This time, instead of there we go. All right, now just fix a few things. So here, this is going to be a minus. I think that's right. Okay. Now, the next thing that we need is Bison and Flex, right? So let's edit our Bison file, and we need to go down. We need our percent token minus, friendly name is minus. That's easy enough. Okay. Oh, this part here. I should have looked this up. I had figured these all out at another time in my past. So one moment, getting there. Yeah, we can just do it there. The minus, and now we will go down to our expressions, and we'll have a new expression here. It's a minus and a new node subtract, and we have to tell it where a node subtract is. So we need to add here. All right, now we've got this. We've got the minus token, so we need to tell Flex. And for that, okay, so this is what I'm worried about. I'm worried about when it is a number, because we accept a minus there, but you know what, we'll see. We will see if this causes a problem. And I need this to be a minus. And first we're just going to see if this runs. Or not runs, but compiles. Okay. Bison, but I'm not seeing the flex. So, oh wait, there's the flex. And it didn't give me an error. Okay, I'm happy about that. Saying vtable for Tang AST node subtract. So I probably left something out. That's fine. Let's go back to, because I was going fast. Okay, AST node subtract. did I forget something in the make file? AST node subtract calls AST node subtract, and it relies on .hpp and the regular HPP. Okay. That all looks good. So what did I do wrong? Whoops, didn't mean to do that. I meant make test. It's going to give me the same error. I know it is. So I'm looking at is there's an error at the bottom. Can you see it? I'm kind of in the way. There we go. Just for the moment. Where it says, so it gets through all the compiles fine. And then the very last, where it's trying to compile the Tang test, we include libtang.so. And it says undefined reference to vtable for Tang :AST node subtract. And normally that means that you left out the C. Oh, yes. That's why. I know why. It means that, yeah, it doesn't have the definition for it. And that is because in the make file, at the very top, I've got these objects. Move myself back down. There we go. I've got these objects, and there's an AST node add. And I need an AST node subtract. You know, I'll put it in alphabetical order. Sure. And now it will be included. Oh, and now, okay, it's trying to do this, and I need to edit the opcode. Good. Okay. Say good. We're getting mistakes. Yeah, but it's working. So this is include. Okay, don't know why I was doing that. And we need to add a subtract. Pop RHS, pop LHS, push LHS minus RHS. Again, just want to make sure that it compiles. And it does. That's always a good thing. Let's check out the tests. Why is this not auto-filling now? I don't know. Your float expression add, and what we're going to do is we're going to say yank 20, and now we're going to say subtract. And for all of these, okay. This is 61 through 80. So we're going to, I don't know if this will work. Colon 61 comma 80. We want to substitute for a plus. We want it to be minus. Will that work, by the way, doing it that way? So it didn't like the plus. Okay, I didn't need the backslash. Okay, fine. And now, do I need to do the same thing again? With 3 minus 5, that's going to be a negative 2. So the 8s should basically become a negative 2. Almost. Let's just... do 8 to become a negative 2. And now let's fix the ones that are wrong. So 3 minus 5 will be a negative 2. 3 point, that's still negative 2. Let's see if we get a, this should be an 8. 3 minus a negative 5. 3.5 minus 5 would be negative, that should be a 1.5. 3.25 minus 5.25. Let's change that to a 7.5 because I want it to be, I guess it's still going to be a 1.5 unless I can't do math anymore. That's possible. Minus 5.5, negative 2.5, and 3 minus 3 minus 5. That should be a negative 5.5. You know what? Let's just see if this works. 77. Because that is P8. And this should also be P8. Victims of my substitution. Okay. So, something has failed because we have pegged out the computer. How do I know that? I can hear it down there. The fans are on and it's going. Oh, let's kill it. There we go. Do you know what's wrong? I do. I didn't tell it what to do when it found the opcode. It should have errored, but it did not. So, let's make it do that. Let's make it error first. And this is going to be source. See now it, oh, because I was using colon B earlier instead of colon E. That's why. So I want program. We need to do dump bytecode. Okay, that's fine. And it's after operator add. Let's just copy these four. Call this but I don't want it globally. I just want it 55, 56. There. That took longer than if I had just done it. Anyway, okay, that's fine. And we also need to edit the source program execute. And this, I think, first we want to say default to be and I'm just going to say dot push back. Error. Unrecognized opcode. And say PC is equal to stack.size. So that'll push it over, and I'm still going to put a break even though I don't need to. Now, I shouldn't have an infinite loop. I may have a something else happen, but yeah, that's fine. I mean, unrecognized opcode, good. And it didn't die on that one. Now I'm kind of curious. It didn't die on number 67. Oh, just 0.3 minus 5? I mean, it didn't give me unrecognized opcode. It returned They should have all been unrecognized opcode. So which ones did not? Point 3. I mean 3 point minus 5 point. And 3 minus 5 point. Oh, I could just look at the numbers. So 3, 4, 5. Wait. Having issues here. 3, 4, 7, 8. 3, 4, 7, and 8. So 3, 4, 7, and 8. What about 9? Okay, so the weird thing is well, 3 has a 5 point. Said that right? 3, 4, 7, and 8. Three, 4, 7, 8. And now we're just looking for the pattern. How are they different? So 3 and 4 have 5 point for the second one. And 7 has 5.25. And this is for the right-hand side operator. These are floats. Positive floats. And 8, again, a positive float. Okay. Where I think the problem is, imagine that I had this. It would read a 3 and a negative 5. Not 3 minus 5, but a 3 and a negative 5. So I think the problem is that we should not be able to we shouldn't be recognizing negatives. I mean, yeah. Can we do that? Which one will it kill up here? Number 5. Number 5. I think that's the problem. So let's do this. I'm not going to fix it yet, but what I'm about to do is I'm going to put in the opcode in program execute. That should fix everything else. And these others are still going to be broken. I'm going to remove the negative thing. Let's do the program execute one. So that's in buffer 3. Add subtract. That's with the capital J. I mean, it's a good trick to know, but it's not what I needed at that moment. And now it says I don't know how to do this. I would need to make the correct garbage collected part. Okay, that's fine. And I don't have that open yet, so E source. No, I want to do the include first. Garbage collected. And this is the one that I forgot to put a, for the operator plus, I forgot to give it any documentation. So we're going to copy that, and we'll just say operator minus and perform a subtraction. Okay, and now let's edit the source garbage collected, and there's the operator plus yank 4. There we go. We're going to make this into an operator minus and call subtract. Now it's going to say I don't know what subtract is. Okay, so we need to add this, and these are to the computed expressions. You say, Corey, we're going all over the place. I know. It's because this is a big complex thing. Source. So computed expression anyway. Include computed expression. There we go. Let's look for add Okay, and now we're going to y6. Subtracting. From, and we're going to call this subtract. And now we need to garbage collected expression add. We will call this subtract. Why? Because we don't know how to subtract these values. And now we need to do the same thing for the integer and all that other stuff. Okay, so we're going to open the include for computed expression float, and we've got an add. We're going to subtract and edit the source for computed expression float. And so here's the add. And now we're making a subtract, and everything's the same except this. Some of these should now be passing. So 1, 2, 3, 4, 5, 6, 7, 8, 9. None of them passed. Then again, maybe I just did bad math earlier. We're about to find out. Okay, I'm going to go ahead and do the and this error message should be don't know how to subtract. And now we're going to do the include computed expression integer. And again, this is going to be subtract. And now the subtract. This needs to be a subtract. That needs to be a subtract. Are we getting anything right? Go back. So for P1, I'm going to cout get bytecode. That's because I want to, oh, it's an, not add bytecode. What is it? If only we had some sort of reference. Dump bytecode. And now we can see, what is it? Integer 3, integer 5, subtract. Seems like that would be rather straightforward. And it looks like it did 5 minus 3 instead of 3 minus 5. Would that be right? Let's see if there's another one. P5 is trying to do -5 minus 3. Is that right? Which would be -8. Okay, so let's double check that. Where would it be? The computed expression, well, probably both float and integer. I probably got it wrong in for both addition and subtraction, but let's try it. Let's look at the float first. That's 9 and then 11. So computed expression float says it's the right hand side. So it's before this. Where does it come from before this? From garbage collected. No, it's from the, well, yeah, garbage collected. But what pops it? That would be the program execution. So there we go. The right-hand side is the back. And then left-hand side. Yep. This should be left-hand side plus right-hand side. And this should also be left-hand side minus right-hand side. It worked. I'm still worried about the minus, though. In fact, we're going to test it. Yep. So I think we're going to have to do minus another way. And as part of that, we're going to number 5 here and number 5 there. And let's now go back to flex. Do I have it? No. I'm going to remove the minus. So P3, P4, and P3, because those are negative numbers. All right. Wait. P3, yep. There's probably a fast way to So you got to do the pass test. Just comment out the stuff that's giving you problems. All right, let's see how I can go about solving this. Give me just a second. We can solve it, but we're going to have to do a little bit more work. What we can do is when we see a minus, right now we're, flex comes along and, hello. There we go. Flex comes along and say this. It sees a 3, it sees a plus, it sees a minus, it sees a 5. With the spaces in there, we could, say that it's, -5 or something, but Flex doesn't know the difference when you remove the spaces. So we can treat it instead as a modifier of the 5. So 5 is just the number, and that, yeah, we could do that. And that would be unary minuses. If I do that, So right now, flex. Just look at that. When it sees a minus, it just tells Bison, hey, I've seen a minus. Okay, let's go to Bison. That is not Bison. Which one is Bison? Don't have it opened. Okay. Bison has token plus, token minus. And I think I can make in my precedence rules. That's right. But it needs to be right associative. And I'm going to call it minus for unary minus, as opposed to binary. Unary, it only has one operand. The not operator is another unary type, right? Not true would be false. It's not binary. It doesn't have two operations. All right, and then is this? Yeah, it's going to be another expression. So the expression that we're going to add, this will be interesting, is the minus expression. But we're going to say use the precedence of our u minus. Our unary minus. Okay. And what do we return? A new Tang, and we have to create a new node, and we're going to call it unary minus. We're just going to do that. No, I think I'll just call it minus. Negative? Yeah, negative. I'll call it negative. You say, Corey, you keep on, well, I'm figuring it out as I go. All right, so what do we need to give it? We're going to feed it in an expression, and that's going to be $2, because $1 is the minus. And in fact, that's it, a location at 1. All right, and is that good? Sure. Now, AST node negative does not exist yet. We can go higher. And say AST node negative, which doesn't exist yet, but it's about to. And where all is this? We're going to have to edit our make file. I'm going to do that right now. AST node integer obj AST node negative dot o. Okay, and now let's tell it where it exists. Where it exists. Float, integer, expression. Let's just do this here. Oh, well, I could have done this. And now we're going to, from 71 to 72, we want to substitute integer for negative more than once. There we go. All right, we're going to, no, copy. Are we going to copy it? Sure. So CP source AST node, which one are we going to do? Integer? Sure, why not? To source slash AST node negative, and CP include AST node integer to include AST node negative. Okay. Now we've got to open these, so include AST node negative. We're going to do a %s and we're going to okay, we'll do it again, %s, and we're going to do all right, now represents a this is going to be operand. The at location. Yeah, I'm not sure. That probably means I need to remove it from the others. Okay, so we've got operand and lock. So instead of this, operand, okay, and let's make copy. this will be okay. Now let's do the source of AST node negative. And we're going to there we go. This is going to be a negative. Okay, so I'm indenting negative, and then on a new line, whatever I'm performing a negative on. The compile, we need to there we go. And now this will be negative. We're adding a new opcode. How do we make a copy of this? Okay. So we need to add a new opcode called negative. Where's the opcodes? Guess I don't have it open. Include opcode. Negative, and we are going to pop val push negative val. Simple enough. Program the dump bytecode and the execute. So oh, forgot my semicolon. All right. how do we do it here? We're going to say negative. All right. And for this, there needs to be one value on the stack. And then operand is equal to stack.back and then stack.pop back. So we're removing it from the stack. And now we're going to say stack.push back negative operand plus PC break. There we go. Now the garbage collection doesn't know how to do this, so we need to tell garbage collection how to do it. Garbage collection. That's 4 and 5. Okay. Perform a negation on the garbage collected value. All right, and we're going to call this oh, there is no that. It's just the one that's there. Simple enough. Buffer 5. Now for this, remove that, and we're going to say negative. We're just asking it for the negative. Negative doesn't exist yet, but we're about to write it. So now we need our computed expression. Just computed expression. 7 and then 6. There we go. I don't want it adding extra spaces. Negative of negating this value. There are no parameters. The result of, there we go. 6. Now we need to write a negation. This is going to be negative. There we go. Don't know how to negate this value. Okay, now we need to do the same thing but for integer and float. So it's basically 8, 9, 10, and 11. This is going to be negative 10. Just copy it. There we go. And now go back to 9, and we will write it. Oh, this is going to be a lot simpler than the others. Garbage collected, computed expression, float, dunder negative, const, and we're just going to say return garbage collected, make computed expression float with the negative this val. And I think it's 11. And instead of float, it's going to be integer, integer. Now the question is did we just solve all of that? Say a lot of steps, Corey. Yep, there always will be. But basically we told, well, Flex already knew how to recognize a minus. We told Bison how to recognize a unary minus, and we created a new AST node for it. And then for the AST node, we had to say, here's how you compile it. So we had to create a new opcode. And for the program, here's how you execute it and print it out when we need to dump it. And then for the computed expressions, we had to say, and what does it mean? It means negation, a negative. And so we had to add that to each one. And yeah. All right, so what is it not like? Probably computer expression CPP 37. Computer expression CPP, that's 6. Line 37. Which means I probably left something out of the HPP. Oh yes, I did. I made a mistake in the HPP. Garbage collected HPP, that's buffer 4. Wait. Computed expression, wait. Oh, number 7. So the negative should not take anything. Did I make any other mistakes? In computer expression float, I have a typographical error. And float.cpp, that's in 9. Line 60. Oh, I was on line 60. And I did the same thing in integer because I copied and pasted. At least I'm consistent. Line 11, I mean buffer 11. Opcode negative needs a colon. For my opcodes, that's buffer 16. Oh, I'm just laughing because, oh no, wait. That's not opcode, that's in program execute. Buffer 3. See if this gets us any closer. Okay, it says we're passing all of it. Let's add back in the tests we took out. We'll start off simple. A negative 42 should give us a 42. And it does. Do all of these pass? They all do. Notice the count's not going up, but now I think it's important. See, all of these are really well behaved. What do I mean by that? I've got spaces everywhere. And I really should write, you know what, I'm going to do it. Let's and this is going to be unary minus. I want to make sure that say, Corey, is this really testing the unary minus? Somewhat. But it's also, so let's do some of these that, so 3 minus 5, I don't need to test all of these versions. 3 minus negative 5 should come out as an 8. Oh, that's not quite, but okay. There. So now on the first number, this should be a negative 8, which I did not. Okay. And I want to do a -3 minus 5. And I should get, yeah, just a 2. Okay, now I like the idea of having a minus 5, which should give me a 5. And that is true. It gives me a 5. And in fact, a minus 5 should give me a -5. That is also true. And I don't think we need to check out anymore, because at this point it seems pretty obvious that it's working. I mean, I could do a minus 3.75 and all of that, and let's just see what it does. Yeah, -9. Is that right? Minus, that's -3.5. Wait. Minus. So -3.5, and this is, so 2 cancels out. 2 cancels out, so it's -3.5 minus 5.25. -3.75 minus 5.25, which is definitely -9. All right. I don't think I need any more, but I do want to do this. I want to do cout P7 arrow dump bytecode. This is just for me. No, is it not? It's not a pointer. Yeah. So now you may say, Corey, shouldn't we optimize this away? Maybe. Negative, and then a float negative, and see, it did catch the subtract. So it's recognizing it properly. Yeah. Now, I think at this point we should quit while we're ahead. I don't even know. Are we an hour and a half in? Probably. No, not quite. Almost. I didn't plan on it taking this long, and I thought we'd get more done. But again, just wiring up all the parts can take a little bit of time. But let's go ahead and, first of all, over here, I'm going to do my get status. See, there's a lot of parts. I want to know what changes I made. So get diff, do I have any blank lines that I shouldn't have? And it also reminds me of all the changes we did, like, you know, the precedence rules. And by the way, if you're wondering, you know, where the precedence rules, you know, that I'm kind of going by, there's the C++ reference, but they're listed in reverse order. That is, top to bottom. We have to give them in the opposite order here. But, oh well. Let's see, what else? We added a couple new expressions. One for handling minus, one for handling negation, which I'm glad we wrote this. There we go. To the garbage collected class. To all of our expressions. Opcodes. Fixed our stupid left-hand side versus right-hand side mistake. Didn't matter with addition because it's commutative. Is that the right word? But subtraction, it does matter. All right. So since I know I'm going to commit all of this, let's do, nope, didn't mean to do that. AST node negative, include AST node subtract, source AST node negative, source AST node subtract. And one last time, make clean, make test. Why am I doing this? Because I want to make sure when I push it, all of everything is, I didn't have a weird state, right? It's all how it should be. Commit -am, because I'm not adding all of those individual. I did look at them. You just saw me look at them. What am I going to call this? I'm going to say add subtraction and unary minus negative. To the language. There. Now, last thing is when you regenerate the docs, sometimes it has to remove stuff. So the best thing to do would be to rm-rf. Be very careful with that command. Docs, and that just, it's gone. And if I say get status, it's going to complain, hey, you deleted everything. Now, as long as I don't commit it, it's not a problem. I could get it back by saying get checkout docs. But now, if I say make docs-pdf, it's going to do its thing. And I expected my computer to make more noise. Get status, and we can see the changes, but it doesn't seem like these are untracked, so these are all new, and then a bunch of modified stuff. And of course, if I pull this out, we'll see in files we've got our new stuff here in our classes. Again, more computed expression types, more AST node types, and those will just grow and grow as our library, as our language becomes more sophisticated. And just wait till we get to things like slicing, well, arrays and slicing, and doing ranged for loops and all that other stuff. Yeah, this will be fun. I'm excited about this. I like making a new language, even though obviously this is a lot of work. Who cares? It's fun. So let's see. Okay, last thing is, say, and I forgot what episode we're on, so let's do episode 15. Yeah, for episode 15. And we are clean. Oh, yeah, git push origin master. And almost there. Git tag -a episode.014. And our message, I don't need quotes actually. Oh, of course, I just said it was 15. And it's there. The last thing I like to do is just to kind of track, is to run clock, count lines of code. And you can see in our C++ code, we're starting to get up there. Yeah. But hey, we're writing a programming language that has its own bytecode and virtual machine execution and unit tests and all that other stuff. So I'm okay with this. All right. So having said all of that, as always, thank you for watching. Let's face it. I know that nobody, well, not nobody. I would love watching it, something like this. I watch other people make things, long projects that are multiple, 3 digits episodes, because I like seeing something come together and understanding how every little part works. That's the goal for this. So again, thank you for joining in, and as always, have a great day.